You take a test for a serious disease, and it comes back positive. The doctor tells you the test is 99% accurate. Your stomach drops. So how worried should you actually be? The honest answer is that you are almost certainly fine. Your real chance of having the disease is about 9%, not 99. 9. And the reason why is one of the most useful ideas in all of mathematics. Here's the trap. When you hear 99% accurate and a positive result, your brain immediately fuses those two numbers together and concludes there's a 99% chance you're sick. That feels airtight, but it isn't. And this isn't just a civilian mistake. When researchers put this exact question to practicing doctors, most of them answered around 90% as well. The question, as asked, is missing one crucial number, and without it, nobody can answer correctly. The missing number is how common the disease is in the first place. Let's say it affects one person in 1,000. That's called the base rate, and it's the thing everyone forgets. So instead of thinking about yourself alone, picture the whole crowd. Here are 1,000 people, just like you. Somewhere in that crowd, on average, exactly one person is genuinely sick. Everybody else, all 999 of them, is perfectly healthy. Now let's give the test to all 1,000 of them and see what actually happens. The one sick person tests positive. Good, the test caught them. But now the healthy crowd. The test is 99% accurate, which means it gets it wrong one time in 100. And 1% of 999 healthy people is about 10 people. 10 perfectly healthy people who are told they tested positive. Not because the test is bad, but because there are just so many healthy people to make mistakes on. So let's gather up everyone who got a positive result. There are 11 of them. One is truly sick. The other 10 are completely healthy and just got unlucky. And you are somewhere in that group of 11 with no way to tell which one you are. So your chance of actually being sick is 1 in 11, about 9%. The test didn't fail. The test is excellent. What fools us is the rarity, because a tiny error rate applied to a huge healthy crowd still produces more false alarms than there were sick people to begin with. And the rarer the thing you're hunting for, the worse this gets. If the disease affected one person in 100 instead, that same positive result would mean a 50% chance. Same test, completely different meaning, just because the base rate changed. This is not only about medicine, it's the same mathematics behind DNA matches in court, spam filters, airport security screening, and tools that claim to detect AI writing. Search for something rare enough, and most of your hits will be false alarms. It's also exactly why a second independent test changes everything, because now the pool you're drawn from is those 11, not the whole 1,000. So whenever someone hands you a scary-sounding percentage, ask the question that unlocks it. Out of how many? A number on its own means almost nothing until you know how rare the thing was to begin with. If that leaves you a little bit amazed, you're in the right place.